Over 30 years ago, Carl Sagan successfully detected life on our Earth. Sagan and his colleagues used instruments aboard the Galileo Spacecraft to conduct a very important control experiment. It's been 30 years since a group of scientists led by Carl Sagan found evidence for life on Earth using data from instruments on board the NASA Galileo robotic spacecraft. Yes, you read that correctly. Among this many pearls of wisdom, Sagan was famous for saying that science is more than a body of knowledge, it's a way of thinking. In other words, how humans go about the business of discovering new knowledge is at least as important as the knowledge itself. In this vein, the study was an example of a controlled experiment, a critical part of the scientific method, and this can involve asking whether a given study or method of analysis is capable of finding evidence for something we already know. Suppose one were to fly past Earth in an alien spacecraft with the same instruments on board as Galileo had. If we knew nothing else about Earth, would we be able to unambiguously detect life here using nothing but these instruments, which will not be optimized to find it? If not, what would that say about our ability to detect life anywhere else? Galileo launched in October 1989 on a 6-year flight to Jupiter. However, Galileo had to first make several orbits of the inner solar system, making close flybys of Earth and Venus in order to pick up enough speed to reach Jupiter. In the mid-2000s, scientists took samples of dirt from Mars, the Mars-like environment of Chile's Atacama Desert on Earth, which is known to contain microbial life. They then used similar experiments as those used on the NASA's Viking spacecraft, which aimed to detect life on Mars when they landed there in the 1970s, to see if life could be found in Atacama. They failed, the implication being that had the Viking spacecraft landed on Earth in the Atacama Desert and performed the same experiments as they did on Mars, they might well have missed signatures of life, even though it's known to be present. Galileo results? Galileo was kicked out with a variety of instruments designed to study the atmosphere and space environment of Jupiter and its moons. These included imaging cameras, spectrometers which break down light by wavelength, and a radio experiment. Importantly, the authors of the study did not presume any characteristics of life on Earth ab initio from the beginning, but attempted to derive their conclusions just from the data. The near-infrared mapping spectrometer NIMS instrument detected gaseous water distributed throughout the terrestrial atmosphere, ice at the poles, and large expanses of liquid water of oceanic dimensions. It also recorded temperatures ranging from -30 degrees Celsius to plus 18 degrees Celsius. Evidence for life? Not yet. The study concluded that the detection of liquid water and water weather system was a necessary but not sufficient argument. NIMS also detected high concentrations of oxygen and methane in the Earth's atmosphere as compared to other known planets. Both of these are highly reactive gases that would rapidly react with other chemicals and dissipate in a short period of time. The only way for such concentrations of these species to be upheld were if they were continuously replenished by some means, again suggesting but not proving life. Other instruments on the spacecraft detected the presence of an ozone layer, shielding the surface from damaging UV radiation from the sun. One might imagine that a simple look through the camera might be enough to spot life, but the images show oceans, deserts, clouds, ice, and darker regions in South America, which only with prior knowledge we know, of course, to be rainforests. However, once combined with more spectrometry, a distant absorption of red light was found to overlay the darker regions, which the study concluded was strongly suggestive of light being absorbed by photosynthetic plant life. No minerals were known to absorb light in exactly this fashion. The highest resolution images taken, as dictated by the flyby geometry, were the deserts of Central Australia and the ice sheets of Antarctica. Hence, none of the images taken showed cities or clear examples of agriculture. The spacecraft also flew by the planet at closest approach during the daytime, so lights from cities at night were not visible either. Of greater interest, though, was Galileo's plasma wave radio experiment. The cosmos is full of natural radio emission, however, most of it is broadband. That is to say, the emission from a given natural source occurs across many frequencies. Artificial radio sources, by contrast, are produced in a narrow band. An everyday example is the meticulous tuning of an analog radio required to find a station amidst the static. An example of natural radio emission from aurora in Saturn's atmosphere can be heard below, and the frequency changes rapidly unlike the radio station. Galileo detected consistent narrow-band radio emissions from Earth at fixed frequencies. The study concluded this could only have come from a technological civilization and would only be detectable within the last century. If our alien spacecraft had made the same flyby of Earth at any time in the few billion years prior to our 20th century, they would have seen no definitive evidence of a civilization on Earth at all. It's perhaps no surprise then that as yet no evidence for extraterrestrial life has been found. Even a spacecraft flying with a few thousand kilometers of human civilization on Earth is not guaranteed to detect it. Control experiments like this are therefore critical in informing the search for life elsewhere. In the present era, humanity has now discovered over 5,000 planets around other stars, and we have even detected the presence of water in the atmospheres of some planets. Sagan's experiment shows this is not enough by itself. A strong case for life elsewhere will likely require a combination of mutually supporting evidence, such as light absorption by photosynthesis-like processes, narrow-band radio emission, modest temperatures and weather, and chemical traces in the atmosphere, which are hard to explain by non-biological means. As we move into the era of instruments such as the James Webb Space Telescope, Sagan's experiment remains as informative now as it was 30 years ago. And this is from the conversation under Creative Commons license published here. Gareth Dorian, postdoctorate researcher fellow in Space Science, University of Birmingham, England. Amazing. This is on Unexplained Mysteries. Please leave your comments. Thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.